Hi guys, so today we will talk about the quite interesting DID method, so the did So why we need why it's so interesting and important, and actually why we need something like did. So we already have a talk about the different DID methods, and majority of these DID methods use the blockchain as a source of trust, and actually we store somehow the DID documents on chain or store the DID documents on IPFS. So, but this actually have some obvious limitations and problems. A couple of these obvious limitations, actually, it's the speed of the resolution and speed of the propagation. The cost for sure, because if you need to pay per DID, you need to pay per transaction, or you could take a look to my different video that described what the site tree and how we could have the massive scale DIDs issuance and limit the costs. So just take a look. It solved the problem of actually the massive issuance, but we still have the problem of the resolution. So it's propagation is not so fast. Especially for the site trees have some downsides, but yet another downside of the on-chain DID methods, actually not just the cost of transaction, but sometimes we have the folks that have the GDPR or some requirements of the security that oblige you to actually control the data, delete the data on request, and if you put something on chain, it's not always easy, and it's still quite hard and interesting philosophic discussion. If the DID is PII, we put the DID document on the public chain, how the PII and the public chain works together, it's a quite interesting question. So what the did peer actually do for us? Did peer is off-chain method, so no chain involved. And how it's actually work? So we have two big parts. First is the peer DID itself, another one is the protocol, so it's the full-scale protocol that allow us to exchange information about and update information about our DID documents peer-to-peer, or even you to many of the peers. So it's possible, and how it's worked that you have concept of the private DID, so it's not publicly resolvable, but it could be resolvable by the people that really matter for you. And for example, a lot of systems have the requirements that for every transaction or for every interaction with another person, you want to have the different DID that will represent you in this kind of transactions. And as you understand, if you will take some on-chain DID method, for every transaction we need to have the different DID, so we need to pay and we need to wait until it will be propagated, so it's not the case. So peer DID methods, they design in a way that we have as usually Alice and Bob, and Alice and Bob just exchange with each other DID documents, and we have no requirements how they do it. They could use the didcom, or they could use the shared space where they have the access to and put their DID documents there. But the main idea of the DID peer that we just exchange our DID documents between 2 points, and they know about each other and how actually they do it. So we have a couple of options. So the first option, and it's the method 0 of DID peer, is just a mimic of the did key. So you generate the key, you have the algorithm that turns this key to the DID hash, and actually that's it. Your DID hash already is enough to reconstruct the basic DID document that have only the sign-in key. So it's extremely limited, it's not upgradable, but it's good enough, and you don't need to exchange anything with anybody because it's self-descriptive. So take a look to the DID key spec. They just follow in DID peer what the DID key do. And one tiny thing that with DAD peer, you could apply some magic to upgrade this basic implementation in the future and extend your documents, but we will talk about this later. Another thing that sometimes you need to share a bit more than just the signing key. You maybe want to share some services and points of authorization rules, and the DAD peer with method 2 will allow you to do it. So it's super easy. You just define the DAD peer. After that, you start with figure 2, and then you put the dot and follow some encoding rules. In this way, you could form quite complex DAD documents without the needs of the resolution. So we have the rules how to turn this bunch of hashes and dots to the full-scale DAD document. And it's not so interesting. These two methods, it's super easy. You share nothing. Your DAD is resolvable by itself, and you don't need to store anything. But I already mentioned that DAD peer is not just a method, it's just a full-scale, full-blown protocol. And here, the method 1 is most interesting for us. So, what does it mean? That you create the cryptographic relation that described in a spec between your hash and your Genesis DAD document. Your Genesis DAD document, that's a regular DAD document with any arbitrary cryptographic inside, so you could put any kind of keys that you want, any kind of sections as you want, but you exclude the DAD hash prefix from it. Because in another way you will have the collision that you need to calculate the prefix that should be included in the document, so you will never be able to do it. So you create this Genesis document, you calculate the cryptographically hash from it according to the rules, and you share this Genesis document with your points. And it's quite interesting that guys try to prevent some fraud activities, and they have quite rich authentication mechanism, and they have the separate role and separate key for sharing this document. That's called the registry key. And you share this document with me, the Genesis one, and I store it on my side in my storage that I control. And when something happens, for example, who wants to add the new key, or your device was stolen and you want to actually remove one of the keys, you just calculate the delta of your DAD document, and via the protocol that defined with the DAD peer, send to everybody the delta, and that's it. So, and in this case, we have full-scale DAD documents that support different cryptography, that are upgradable and controllable, and the most important, that you just save the costs, money, transaction time, propagation time, and all other things, because you just don't have the central storage that needs to handle trillions and trillions of these peers. Everybody just store their own documents of their interactions somewhere in their storage, and you have the full protocol to control it. It's quite interesting. I have a couple of SDKs and projects that actually implement the Git peer. Right now we have quite good implementation of Git peer in Python and Java, not so much full-scale protocol in JavaScript or TypeScript. I'm still quite keen to create it, but with the Git peer we really solve the high frequency upgradable and all of the things exchanges between the DADs. So it's a really interesting method. I believe that we will have more off-chain methods in the future. So I recommend you to take a look to the specification. I will leave the link on the video, and for sure follow my channel, share your experience, what you build for the decentralization world, what you do with DIDs, how you understand them, and maybe you have some fancy cool use cases where you just use the DIDs for example, the signing documents or something. So I keen to hear more from you, and right now the choose and enjoy the tea.